these in grade 9, even though we weren't not supposed to. But anyway, you guys know how to evaluate exponents like positive exponents, whole numbers, 1, 2, 3, 4, etc. You know how to evaluate an exponent that's raised to the 0. Anything to the 0 is always 1. Good. And last year, and what we'll review right now, negative exponents. Negative exponents doesn't mean a negative answer. Okay? Negative exponents involves fractions for the bases, not for the exponents. So just to prove to you how we evaluate negative exponents, consider 3 squared divide 3 to the 5th. There's a couple ways I could do this. Well, I could write them out. So 3 squared is the same as 3 times 3 on top. Then I'm going to write a division bar instead of this symbol. And on the bottom, I'm going to write out 3 to the 5th by writing 5 3s. Your knowledge of fractions, you should be able to look at this and say, can I reduce anything? Can I? Like, couldn't I divide this 3? Everything's getting multiplied, so couldn't I divide this 3 by 3 and this 3 by 3 to get 1 and 1? Anything else I could reduce? Another 3, another pair of 3s, divide each by 3 and they go down to 1. Well, there's no more 3s up top to reduce with a 3 on the bottom, so I'm done. So I am left with 1 times 1 up top, which is 1, over 3 times 3 times 3, which if I write back in exponent form, I get this. 1 over 3 to the positive 3. Or I could write it like this. These two mean the same thing. Because 1 to the 3 is still 1, and 3 to the 3 I'll just leave. I won't change it to 27, I'll just leave it in exponent form. So when we divide 3 to the 2nd, divide 3 to the 5th, we get this. Another way you could divide it is using your knowledge of exponent laws. When I divide 2 powers with the same base, what happens to the base in the answer? When I divide 2 powers, it stays the same. What do I do with the exponents? Subtract them. So here I'm going to go 2 minus 5. And I get a negative exponent. So 3 to the 2nd divided 3 to the 5th can either work out to this or this. Even though they look different, these mean the same thing. Because they're both the answers that we get when we do 3 squared divided 3 to the 5th. So we can say that these two must equal each other. Let's do a big equals. Although now it doesn't even look like an equals. Okay. So we can say that 3 to the negative 3rd is equal to 1 over 3 to the positive 3rd. With me? Okay. Look at this. What if I asked you, you don't have to write this down, looking at this to see how this equals this, what do you think this would equal with a positive exponent? Yeah, because notice We just change the negative to positive, and the 3 becomes 1/3. What do you think that might be using a positive fraction? So the negative becomes positive, but what do I keep doing to the base? Flipping it, which is the same as finding the, not the inverse, begins with an R, reciprocal. Although multiplicative inverse is correct. Okay, so that's how we evaluate negative exponents. If you've got a negative exponent, make it into a fraction, if it already isn't a fraction, and then flip the base, find the reciprocal of the base, which allows me to make the exponent positive. And why do we want to make the exponent positive? Because we know how to do those. So notice that usually when we encounter negative exponents, the answers are going to be fractions. So let's look at a few examples. These would have been similar to ones we did last year. So you're asked to evaluate each one of these. First thing you should do, write it with a positive exponent. What is this? How do you write 3 to the negative second using a positive exponent? Take the 3, make sure, put those parentheses in, and I get to the positive 2. You need the parentheses if they aren't already there at the beginning. Okay, so what's 1 over 3 squared? 1/9. Done. How do I write b with a positive exponent? Like this? Parentheses. These are brackets. And what is 4/3 to the positive 3? Well, that's the same as 4 to the 3 over 3 to the 3. 4 to the third, 64 over 27. Good. This next one, how do I write with a positive exponent? 1/-2. You don't change this. Only the exponent is changing from negative to positive. So it's 1/2 to the 1/-2 to the positive 4. What's 1 to the 4th? What is -2 in parentheses to the 4th? Come on. -2, but it's in parentheses to the 4th. Okay. Somebody want to help? 16 or -16? Why? Because good. Yes. What's that? Okay. So let's combine what we learned. Hi. Why are you looking at me like I'm the one with the problem? See, now you distracted me, and now our exchange is on video for all to listen to. And now you can't even make eye contact with me. Now you just. See, now that's a little creepy. Okay, let's take what we learned last class and combine it with what we just did. How would you evaluate 25 to the negative 1/2? What? It's crazy. So what's the first thing you do when you see a negative exponent? Flip the base and make it positive. So 1 over 25 to the 1/2. And in the last lesson, when we saw a fraction exponent, what did we always change it to? Well, not necessarily a square root. In this case, it'll turn out to be a square root, but what do we call that whole group of square roots and cube roots and fourth roots? What's the word? Radicals. Good. So how do I change this to a radical? Square root, and you don't even have to write the little 2 outside. 1 over 25. And what is the square root of 1 over 25? Well, it's the same as the square root of 1 over the square root of 25, which is 1 over 5. Okay. So now we can combine, so this is new, because the fraction exponents are new this year. So let's try a couple more. As soon as you see a negative exponent, first thing you do, don't change the fraction yet. Change the negative exponent to positive. So it's going to be 1 over 8 to the positive 2 over 3. And you don't flip the fraction in the exponent. You flip the base. Remember that. How do I write this now? Because if it's a fraction, I got to change it to a radical. How do I write it? Mm-hmm. 8 on the outside? 8 on the outside. Okay, so the 3 goes here. Yeah. 1 over 8, yeah. To the power of 2. Good. So what is the cube root of 1 over 8? Well, the cube root of 1 over the cube root of 8. And don't forget, we still have to square this. So 1 over 2 all squared, 1 over 4. Good. See if you can tackle the last one. Don't shake your head. You can do it. Yeah, you kind of like that. All right, well, if you didn't shake your head, you didn't shake your head. I guess I'm seeing things. What's the first thing we're going to do? Flip what?
The base.
Flip the base, which allows me to make the exponent positive. Good. Fraction exponent means go to radical. What the? Am I connected or not? I think I'm still connected. Okay, anyway. So the 16 over 9 goes under the radical. Here, 2 per square. And because there's a number besides 1 here, I need parentheses, raise it to the third. Okay, so now I got to do what's inside the parentheses. Square root of 16 over square root of 9 Good. And I still have to raise that to the third. 64 over 27. Good. Cross out example 3. We're not going to do that one. Example 3, this really has to do with how do you how do you use a calculator with fraction exponents and negative exponents? And we're not going to worry about that. Okay? Which means I want you to, for Thursday, exercise 1.6, but I want you to omit, as in don't do, numbers 3 and 5. Okay? You'll definitely want to practice with those ones on the front page. Okay? If you can get those and gain a better understanding of them, you're in good shape. You're right there, Calissa? Okay. You're happy today? Or you're happy every day? That's okay. You don't have to talk to me.